Hello everyone, and welcome to World Wonder. Today, we're going to talk about a super cool topic. What would Venus look like if humans could transform it? Exploring the possibility of transforming Venus ignites imaginations and challenges our technological prowess. As humanity gazes towards the stars, the concept of making the second planet from the sun, our new home represents the ultimate frontier in space colonization. Understanding Venus is crucial to this endeavor. This celestial neighbor, shrouded in thick clouds, has long captivated astronomers and scientists. Its proximity to Earth and similarities in size and composition make it a tantalizing target for exploration and possibly transformation. However, the extreme conditions on Venus present formidable challenges. With surface temperatures hot enough to melt lead and atmospheric pressure crushing enough to immobilize humans, the hurdles to colonization are not merely technical, but also existential. The concept of terraforming, or making Venus habitable, offers a solution to these challenges. This ambitious idea involves altering the planet's hostile environment into one where humans could live and thrive, fundamentally changing our relationship with the cosmos. Historical perspectives on Venus exploration provide context for these futuristic visions. From ancient observations to modern spacecraft missions, our understanding of Venus has evolved, laying the groundwork for the audacious idea of transforming it into a second Earth. Venus and Earth share a striking number of similarities, earning Venus the title of Earth's sister planet. Both possess nearly identical sizes and compositions, suggesting they might have shared a similar starting point. However, the paths they've taken through the eons have led to drastically different worlds today. One of the most formidable challenges to human colonization of Venus is its extreme conditions. Surface temperatures soar to a scorching 900 degrees Fahrenheit, hot enough to melt lead. The atmosphere, primarily carbon dioxide, exerts a crushing pressure 92 times that of Earth's at sea level, creating an environment far from hospitable. The concept of terraforming, or making Venus habitable, hinges on overcoming these harsh conditions. Scientists propose ambitious strategies to cool the planet and modify its atmosphere, transforming Venus into a world where humans could potentially live and work. This long-term vision involves cutting-edge technology and innovative engineering solutions. Historically, Venus has captivated the imagination of astronomers and explorers. Initial observations painted a picture of a lush, Earth-like world, but further exploration revealed its inhospitable nature. Despite this, the allure of Venus as a potential new home for humanity persists, driving forward our quest to understand and possibly transform it. The greenhouse effect on Venus poses a significant problem, but also offers insight into potential solutions. Venus's thick atmosphere traps solar radiation, leading to its extreme heat. Addressing this issue requires innovative approaches, such as using space mirrors to reflect sunlight away or introducing microorganisms capable of altering the atmospheric composition. Harnessing space mirrors to deflect sunlight is a groundbreaking approach aimed at cooling Venus's scorching surface. By positioning vast, reflective structures in orbit, scientists propose to reduce the solar energy reaching Venus, potentially lowering its extreme temperatures. This method offers a direct intervention to temper the planet's hostile climate. Introducing microorganisms capable of altering the Venusian atmosphere represents an innovative strategy. These microscopic life forms could be engineered to consume carbon dioxide, reducing the greenhouse gases that fuel Venus's furnace-like conditions. This biological solution promises a gradual yet potentially effective means to transform the planet's atmosphere from the inside out. The construction of durable habitats is essential for human survival on Venus. These structures must withstand extreme temperatures and corrosive atmospheres, challenging engineers to innovate. Utilizing materials resistant to such conditions, along with advanced climate control systems, these habitats could offer a safe haven for pioneers. Terraforming Venus raises profound ethical questions. Altering an entire planet's ecosystem for human habitation prompts debates about the responsibility towards untouched celestial bodies. Critics argue the need to consider the long-term consequences of such interventions, advocating for a cautious approach that respects the natural state of celestial entities. International collaboration emerges as a vital component in the journey to transform Venus. The scale of the endeavor necessitates pooling resources, knowledge, and technology from around the globe. This unified approach not only accelerates progress, but also fosters a sense of shared purpose in the quest to expand humanity's horizons. The financial implications of a Venus transformation project are staggering. With the current level of technology, the investment required to make Venus habitable would dwarf any space mission undertaken so far. Funding such an endeavor would likely involve international collaboration, private investment, and possibly the creation of new economic models dedicated to space exploration. Addressing Venus's slow rotation is another hurdle. Venus spins very slowly on its axis, resulting in extremely long days and nights, which could pose significant challenges for climate regulation and human adaptation. Innovative solutions, such as artificially altering the planet's rotation or creating habitable zones that can withstand these extremes, are under consideration. The concept of creating a magnetic field to protect Venus from solar winds is pivotal. Without it, any atmosphere artificially generated could be stripped away by these winds, much like what is believed to have happened to Mars. The technology to create an artificial magnetosphere is still in its infancy, but holds promise for not just Venus, but future planetary protection efforts. Importing water to Venus presents a logistical and engineering challenge unlike any humanity has faced. The feasibility of such an operation depends on the development of space transport technology capable of moving vast quantities of water across the solar system, or alternatively, the ability to unlock water from the planet's own resources, if available. The idea of synthetic photosynthesis for producing oxygen on Venus opens a new frontier in terraforming. This approach would not only provide a breathable atmosphere, but could also help regulate the planet's temperature. However, scaling this technology to affect an entire planet's atmosphere requires significant advancement in bioengineering and energy supply strategies. Creating a magnetic field around Venus is pivotal to shield it from solar winds, which can strip away atmosphere and water molecules. Implementing artificial magnetosphere technology could mimic Earth's natural protection, ensuring a stable environment suitable for human habitation and protecting essential atmospheric components from being lost to space. The concept of importing water to Venus challenges our current technological capabilities, but remains a cornerstone of making Venus habitable. Methods might include redirecting comets or ice-rich asteroids to collide with Venus, providing not only water, but also potentially altering its atmosphere, a crucial step towards creating a livable environment. Synthetic photosynthesis offers a promising avenue for producing oxygen on Venus, utilizing engineered microbes or artificial leaves. These could convert the planet's carbon dioxide-rich atmosphere into oxygen, fundamentally changing the planet's habitability. This approach not only aids in terraforming, but also provides a sustainable oxygen source for colonists. Soil creation and agriculture on Venus would require initial use of hydroponics and aeroponics, utilizing mineral-rich water solutions to grow plants without soil. Over time, converting the barren Venusian surface into fertile soil through microbial and chemical processes could support traditional agriculture, sustaining human life and biodiversity. Terraforming Venus impacts Earth's environment, raising concerns about resource allocation and environmental degradation. The extensive use of materials and energy for such a massive project could strain Earth's resources. Conversely, successful terraforming could relieve population pressure on Earth, offering a new frontier for humanity while encouraging technological advancements in sustainable living. Legal and sovereignty issues in colonizing Venus present a complex web of challenges. International space law dictates that no nation can claim sovereignty over celestial bodies. Yet the practicalities of terraforming Venus could necessitate a re-evaluation of these agreements. The prospect of transforming Venus raises questions about who would govern this new world and how laws would be enforced in an environment vastly different from Earth. Artificial intelligence, AI, plays a pivotal role in the Venus transformation project. AI systems would not only assist in the planning and execution of terraforming strategies, but also in managing the delicate balance of a newly habitable environment. These intelligent systems could oversee atmospheric monitoring, resource allocation, and habitat construction, ensuring the project's success. Public perception and support for Venus colonization could vary widely. The ambitious nature of transforming an entire planet might inspire awe and support among many, yet others could view it as hubris or a misallocation of resources. Garnering widespread public support is crucial for securing the funding and international cooperation needed for such a monumental task. Training the first human settlers for life on Venus involves preparing them for conditions unlike anything on Earth. This includes not only physical preparation for Venus's harsh environment, but also psychological readiness for the isolation and challenges of living on another planet. These pioneers would need a diverse set of skills to build a new society from the ground up. The potential for discovering ancient life or artifacts on Venus ignites the imagination. While the extreme surface conditions make it unlikely, if terraforming efforts reveal signs of past life, it would have profound implications for our understanding of life in the universe and Venus's history. Such a discovery would also raise ethical questions about our right to transform the planet. The psychological impact of living on a transformed Venus cannot be underestimated. Settlers would face not just the physical challenges of a new world, but also the mental strain of isolation and the profound shift in lifestyle. Adapting to a slower Venusian day and coping with the absence of familiar Earth landscapes would require robust psychological support systems to help colonists maintain their mental health. Comparing Mars and Venus as targets for colonization reveals distinct challenges and opportunities. Mars, with its more temperate climate and evidence of water, has long been the focus of colonization dreams. However, Venus, with its thick atmosphere and closer proximity to Earth, offers unique advantages for atmospheric manipulation and solar power generation. The involvement of private companies in space exploration has significantly accelerated the timeline for potential colonization efforts. These companies bring innovation, flexibility, and funding that traditional government space agencies may lack. Their competitive drive could make Venusian colonization more feasible by developing cost-effective technologies for terraforming and habitat construction. Venus could serve as a stepping stone for further space exploration, offering a unique environment for testing life support systems and other technologies critical for long-duration space travel. Its challenging conditions provide a proving ground for technologies that would enable human survival in the extreme environments of outer space or on more distant planets. The challenges in maintaining a stable climate on Venus are immense. The planet's thick carbon dioxide atmosphere and proximity to the sun create a runaway greenhouse effect that any terraforming effort must overcome. Innovative solutions, such as space mirrors to reflect sunlight or large-scale atmospheric scrubbers, would be essential to cool the planet and create a stable, habitable environment. Establishing reliable communication systems for Venus colonists is paramount. The vast distance from Earth requires advanced technology to ensure messages are transmitted quickly and securely. Innovations in satellite networks could provide constant real-time contact, vital for the safety and well-being of those daring to call Venus home. The potential for energy production on Venus presents unique opportunities and challenges. The planet's dense atmosphere and proximity to the sun could be harnessed for solar power, offering an abundant energy supply. However, adapting these systems to withstand Venus's harsh conditions will be a significant engineering feat. Introducing a water cycle on Venus involves creating lakes and oceans, a monumental task that would fundamentally alter the planet's landscape. This would not only support life, but also regulate temperature and atmospheric conditions, making Venus more Earth-like. The engineering and ecological efforts required would be unprecedented in human history. Biodiversity is crucial for a stable and sustainable ecosystem on Venus. Introducing plant and animal life would begin with the most resilient species, gradually expanding to a diverse biosphere. This step would mark a significant milestone in making Venus a living, breathing planet, echoing Earth's rich tapestry of life. The future of humanity on a transformed Venus sparks the imagination. It represents not just survival, but the flourishing of human innovation and spirit in the cosmos. As we overcome each challenge, from communication to biodiversity, we inch closer to making what once seemed like science fiction a reality, opening new chapters in human history and exploration. So, let's look forward to our future space adventures and work towards realizing this dream. Remember to subscribe to our channel and follow our scientific journey as the future is full of endless possibilities. Thanks for watching, and we'll see you in the next installment.